Hello, everyone. My name is Jakub Kubryn, and I'm going to talk about I'm going to talk about the JPA, so something that should be widely known, but all Java-related developers that are doing some backend stuff, but in fact it doesn't. So I'm doing JPA-related trainings for over 3 years right now, and I see that there are a lot of things that are strange to even senior developers, and they don't understand how something works. They don't understand what are the consequences of some actions we are taking. So this talk is a little bit just a JPA training in a nutshell. So it's an extract from whole 2 days training, but I think we'll cover the most important stuff right now. Okay, so 2 words about me. I'm on a daily basis working as a co-founder of DevSkiller. So it's online skills assessment platforms where we are checking the real knowledge of the software developers, which means if you have too many poor candidates on a job interviews, then we can help you filter out them using some real world stuff. Like in Java, these are full-blown Maven projects with databases, with JPA, with Spring, etc. I'm also doing trainings at Bottega company. I'm a part of the program committee at DevOps Poland. And I'm also a co-founder of the Spring Cloud Contract. It's a great tool. When you are working in a distributed environment, you have some contracts between server and customers, then Spring Cloud Contract can help you live and take quality without spending time on end-to-end integrational tests. Okay, you can follow me on Twitter when I'm posting some interesting stuff, I think, about Java, Java performance, and JPA. Okay, so the current problem-solving algorithm, which is really widely implemented by almost all developers, is really simple. Google, for the error message, copy-paste the solution from StackOverflow, try, repeat. Google, copy-paste, try, repeat, etc. Okay? And we are just breaking this loop when everything is working correctly. The problem is that we need to add one more really important step to this whole solution, which means we need to add the understand at the end of the loop, okay? So I need to check why this solution is working. Maybe I've just exposed my application to the whole world because I've turned off the authorization. Okay, oh, yeah, maybe, but it's working. I had problems with cross-region request policy, and now everything is working. Yeah, because you're exposing everything to everyone with star in the URL. Okay, but it works. Okay, so yeah, problem solved. Okay, so the problem is that in JPA there are a lot of things, a lot of traps waiting for you. And let's start by something standard. So there is a simple class. It's a product class with some identifier and name. What's wrong with this code? What's wrong here? Okay, so generally the column annotation does exactly nothing. Okay, it's just a holder for some specific DDL stuff. If you want to change the column name, set the length of the column, set if this column should be nullable or no, then you can use the column annotation and use particular attributes. But when you are not putting any attributes, this column annotation makes no sense. Okay, because hibernate will save all fields that are present in the entity and that are serializable or not transient. They are all persisted automatically with default mappings. So this column annotation makes no sense. What's wrong with this part of code? Standard transactional service, what's wrong here? What's safe? Yeah, so generally safe also does nothing here. Why? Because as long as the entity is being managed by the hibernate, hibernate checks if this entity has been changed, and if anything has been changed, it's persisting it to the database. So it's a dirty checking mechanism. So what's the problem with putting safe at the end? Okay, it does nothing, but it's not so great problem. The problem is that I saw many times where people were doing some logic here, changing the entity state, and then checking if something, then save. Okay, so if this condition is untrue, they say, okay, it won't be saved to the database because I'm not invoking the save method. Okay, and in fact, it was being just saved to the database, which was a huge consistency problem for the application logic. Okay, so remember about the dirt checking. This new price will be persisted even if there will be no save line, because this is transactional, it's in the same transaction. Hibernate will care about that. Next step, fields versus getters. Okay, it's all about religion. So should the annotation be present in the field or on getter? So who thinks that annotations should be present on fields? Just raise your hands. Okay, and who thinks that annotations should be present on methods? Okay, so generally, to be honest, both are okay as long as you are not working together in one team. Okay, why? Because it's not about religion. It's about to DDD or not to DDD. Okay, if you are using annotations on fields, then it means the engine or engine won't use any getters or setters for accessing the fields. So we don't need getters and setters in our entities, which means there can be hidden by some business methods or something like that. Okay? If you are putting the annotation on a getter, then we are using the Java bean access, which means getter and setters to access the fields or the values. And the problem is that even a single annotation on the method is changing the access for the whole class, which means adding an ID annotation on a getID won't persist the name if there is no getter for name. Okay, so that's the serious problem, because changing one access changes this access for the whole class. And of course, we can use mixed access, but we need to directly tell Hibernate, hey, use the field access for this entity instead of this method, because this method should use the property access. Without this annotation, name won't be persisted if there will be no getter for that. Okay, so remember about that, because if you will add one annotation on getter, you can change the complex logic of the class. Let's move to another example. There is a simple entity with order. Okay, it can contain some products, but it's not important. What's wrong with this piece of code? Order is a keyword, which means when you are trying to save it, it just blows with some grammatic SQL exception. So what are we doing with that? Google, find a solution on StackOverflow, paste, bah, check, works. There is insert into orders, exactly what I wanted to achieve. So now let's try to load this entity. So I'm doing the HQL query, select O from order O, bam, it's not working. Why it's not working? There is an order entity, and I want to ask for this entity. But it's not a class name, it's name of the entity. Usually, we have a convention that entity name is equal to the class name, but it's just a convention. And here, I've overridden it with the configuration, which means the entity name is not longer order, it's orders. Okay? So generally, it's not something that I wanted to achieve, because now, okay, I'm able to save, but all my queries and all my conventions are not working correctly. So what is the correct solution here? Table annotation. Okay, table, exactly like the column annotation, just a holder for the mapping on the database side. Okay, so here, entity, okay, this is the entity, it has normal name, and table is changing the name of the entity to something that I need to use on my database side. Okay, let's move on to mappings. Mappings is the most important thing about Hibernate, because Hibernate is all about mappings. So one-to-one mapping, really simple mapping. Customer has an address, and address has a customer. What's wrong with this really simple piece of code? Yeah, this relations has two sides, which means Hibernate doesn't know which side is owning this relation. So it will create two foreign keys. There will be foreign key from the customer to address and from the address to the customer, which means how can I remove those objects? How can I remove customer? I can't because there is a foreign key. On the other hand, yeah, there is also a foreign key, so I'm not able to remove that. Okay? So I need to add mapped by here to say, okay, this is the inverse side. I'm owning the relation, so there will be only one foreign key. But let's move to the next example, one-to-many. What's wrong here? Okay, it's one-to-many relation, so we don't need any linking table here, right? But Hibernate will create a linking table here, just by default. As long as there is no join column annotation, Hibernate will create linking table even for one-to-many relations, just because. Okay, there is no good argument to do that, but they are doing that. And talking about the good arguments, what's wrong here? It's just a many-to-many table. How can we screw the many-to-many relation? Any ideas? Yeah, two linking tables. So by default, Hibernate will create two linking tables for many-to-many relation. So there will be 4 tables for this piece of code. There will be customer for customers, address for addresses, customer address, and address customer. Does it make sense? No, but that's how Hibernate works. I also need to use mapped by here to say which part of the this relation is the owning side. It's something with the projector because I see slides here. Okay, I will continue talking. Sorry. So now the next important thing about the Hibernate is the lazy loading. Lazy loading because we want to load the element only when this element is needed, not when we are just retrieving one object. I don't want to retrieve the whole graph, okay? Because it costs transfers, it costs memory, etc. So we know that Hibernate is doing proxy by subclassing. It's using JavaSys or CGLib tools to do that. And when you are going to subclass some class, then of course there are some requirements that you need to meet, which means this class cannot be final, because I cannot extend final class. I cannot extend properly class containing the final methods, because then I'm not able to override those methods, okay? This entity must implement a default non-private constructor to be able to do that, etc., etc., etc. So there are a lot of constraints that you need to follow when you want to use lazy loading. But it's not true, because usually we use lazy loading only on collections, right? There are really a few examples when you want to use lazy loading on some private fields or primitive fields like strings, okay? So it's great because all collections in Java are backed by interfaces, okay? So I don't need to create the proxy of the entity containing the collections, because I can use my own implementation for set or for list, okay? Which will contain the proxy inside of the implementation. So Hibernate is not using hash set, it's not using array list, it's using persistent set or persistent list, which inside is doing the proxy. Okay, so that's the good information, because no proxy is needed for lazy loading the collections. Okay, and the important thing is there are 3 types of collections in Hibernate. There are set, bags, or lists, and here is the set. Okay, set is the most simple collection implementation in Hibernate. As I said, it doesn't allow you to have any duplicates, and there is no order in sets, right? So working with sets is really efficient, because if you want to delete an element from this collection, there is just one delete statement. When you want to update some element, then there is one update statement. when you want to add an element, there are just two queries. One to load all items, to check if this element you are going to add is in fact unique, and the second, to insert the new item. But please take a look at that. What's this type of collection? It's not a list, it's a bag. And what's wrong with bags? Bags allows duplicates exactly as list, but there is no order information, okay? So I'm using list in Java because I care about the order. Or I want to just be able to invoke the getZero method, but it's just an anti-pattern, okay? So I use list because I care about the order, and Hibernate doesn't care about the order because it's not a list, it's a bag, okay? And the problem is that if you want to add a new element to this list, to this bag, we don't know if you are adding a duplicate or you're adding some new element. So Hibernate needs to recreate the whole collection, which means it removes everything from the database for this collection, for this relation, and add one more time all items. If you want to delete some element of this list, Hibernate needs to recreate this whole list. So it removes everything from the database and inserts all elements that are still after removing in this list. And if you want to update, then it's simple. Then we just able to update. Of course, it's true only when you have a linking table, because without linking table, we can just add or delete using the entity ID. But if we have a linking table, then I don't know if this is a duplicate. There is no unique identifier in the linking table, okay? So I need to recreate it all the time. So how can I use list in a Hibernate? I still using a list on a Java side, which makes sense because list is list, okay? But I need to add an order column annotation which tells Hibernate, okay, this is a list. So please add one more column. In this fact, it will be a product index or product order, which will contain order of all elements, okay? And now one more time, if you want to update this list, delete something or insert, Hibernate will just invoke one insert statement, but it also needs to fix the ordering, so it needs to update all other elements. Of course, if you are adding to the end, there is no problem. But if you are removing something from the middle, then it needs to reorder the rest of the implementation, okay? So now let's move to the performance issues in Hibernate, which are also really common, and it's n+1 select problem. It's the most popular performance issue in the Hibernate or JPA world. And the idea is really simple. I have a user with addresses list which is lazy loaded. And now I'm asking my database to retrieve the list of the users. Okay? And now for each user, I'm iterating over the addresses list or are just using the addresses list, which means for each user, I need to provide or execute the query to load the addresses list, right? Which means for any users, there will be n times query for getting the addresses list, okay? Plus one query for retrieving the users list, which means there are n+1 selects for solving such a simple example, okay? And how can we deal with that? At the beginning, I need to discover that this problem exists, okay? And there are two ways of doing that. First, the most simple is that you need to dig into the logs, check the logs, okay? And if you see that in logs there are a lot of queries, probably you are facing the n+1 select problem. Also, it's possible to use Hibernate statistics even in unit tests, or in this fact, it will be more than integrational test, to ensure that the number of the queries inside some particular business method is equal to 2, 3, not 103. Okay, so we can use Hibernate statistics in unit tests to see if the problem of n+1 selects exists. And how can we solve that? There is a simple workaround for this one. We need to specify a batch size of 10. which means if you are iterating over a collection, Hibernate see, okay, so you are asking for an addresses list, but in fact you are asking for the element, for the entity, which is inside some other collection. So I will retrieve not address list not only for this one user, but also for the next 9th user. Okay, so I will have not n plus 1 select, but n divided by 10 plus 1. Okay, so it's better, but it's not good. One more time. If you want to solve this problem, you need to fetch. So I'm using a select u from user u, join fetch u.addresses. So I'm fetching this one, okay? Of course, I can use also a criteria API, which is present since JPA 2.0, and it will do exactly the same, okay? Only way to solve the n plus 1 is to say explicitly, I want to fetch this collection here. Another problem is that if you want to fetch something here and you want to fetch something on the addresses, for example, it won't work with bags. Okay, if you have a bag and another bag, so two lazy loaded collections, Hibernate won't allow you to invoke the query because then it cannot see where are the duplicates. It works for sets, it's worked for lists, but it won't work for bags. Okay. Next thing I'm going to cover is how we can save our entities. There are two methods on the entity manager. One is called the persist, second is called the merge. Okay? Persist, this deals only with new entities, always. When you pass some entity that's managed, persist will ignore it. The problem is that merge looks pretty good because it works with new entities as well as with detached entities. So I don't need to check if this entity is new or this entity is managed entity, but it's detached currently. I can always invoke merge and everything works out of the box. Everything except the performance, because how merge should realize that this entity is new or it's detached entity? It needs to ask the database. So merge is invoking the database query, okay, to see if this entity exists. And if it exists, it's merging it into the entity manager context. And if it doesn't exist, it's inserting it one more time. So that's how it works. So there is really performance issue with merge if you want to use it all the time, not only for the detached entities, okay? And the next stuff, really important here, is the optimistic locking, okay? Optimistic locking is really useful, especially when we are going to use, let's say, multi-threaded programming, okay? Because optimistic locking is not about ugly users that are trying to save the same entities at the same time. It's usually because of our mistakes in a concurrent programming, which means I'm doing something with the entity, and on the other hand, I'm doing something with the same entity asynchronously in other thread. Okay, and there is some race condition behind those threads, and it finishes with optimistic lock exception. Okay, which means Hibernate is not locking the entity out of the box. It's just using some versioning, which means if you are going to update the entity, the update statement is update entity set something 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 where ID equal to 1 and version equal to 3. Okay? And if the version in the database is equal to 3, then database says, yeah, 1 row updated. And if the version is not met, and we know that ID is met because we are updating the entity which we retrieved from the database, database will say, sorry, 0 rows updated. So I know that the version is incorrect, that the version has changed, which means I can throw the optimistic lock exception, okay? The good thing is that when you decide to use versioning, you can use integer, which is pretty obvious, but you can also use a timestamp. And what's the idea of using timestamp as a version? We get the last update date for free from Hibernate. So I know when my entities were updated. So I can use it to some, I don't know, secure REST framework or something like that when you want to use reporting or put those entities into another, I don't know, into some another database, into some non-relational store or something like that. Okay, so that's the idea behind optimistic locking. We are checking version to ensure if no one was changing this entity the same time, but we are not locking it. Okay, so it's why it's called optimistic locking. And the problem with optimistic locking is that nowadays we are all using the REST services with some Angular or Backbone.js frontend. Okay, and the problem is that there is no optimistic locking in REST. Why? Because we are retrieving the entity from the database. Then we are serializing this entity into some DTO object, data transfer object, sending it using the JSON to our frontend, and then frontend is sending out a data or a delta or something like that. Okay, and where we are checking the version only during the save method. Okay, so I'm invoking the put method in my REST framework, and then I'm retrieving the entity. I'm setting new fields and I'm saving it. But I'm not comparing if the version I've sent to the client is the same as version retrieved during the save method, right? So the issue is that if you are going to use optimistic locking in REST, then you need to serialize the version as well as the payload of the entity. So all my DTOs must contain version information which needs to be sent back to the server during the save method. And then after retrieving the entity, you need to check if those versions are equal. Okay? If you see that customer sends you an information, hey, there is a new version of this user, I started from version 5, and you see that there is version 7 in the database, you know that this entity was changed during this change. And it can take like 20 minutes for the user in REST to fill some form and send it back to the server, okay? So on the server side, it was usually a seconds, and we were facing the optimistic lock exception. Now there are minutes, and everything is okay. No optimistic locking, it's strange. So when something is strange, then we should go deeper and check why it's happening, why it's like that. And then you will realize that it's because of we are not sending the version to the user. Okay, so please remember about that. The next thing is really trivial Java methods equals and hashcode. Okay, we all use it every day for every class we are starting. And what's the problem here? What's the problem of implementing equals or hashcode in the entities? Yeah. Exactly. Equals and hashcode needs to work on immutable fields. And generally, there are no immutable fields in entities. I could use an ID. ID is unique, it's immutable, but it doesn't exist on a new entity. Okay? When the ID is assigned by the database using sequence, auto increment or something like that, it exists only after saving entity. Okay? So imagine the situation. I'm creating a user and I'm creating the address. I'm adding the address to the hash set on the user, and then I'm persisting everything to the database, and I want to retrieve this address from the set. And said, hey, there is no such entity. Why? Because ID has changed. Okay? So the problem is that we can't use ID and we can't use anything else because any other fields are not immutable. Okay? And it's the real problem when you think about that, because there is no good way to solve it. Okay? The best way, but not the good way, it's to use a UUID, which means when you're creating a new entity, you always assign the unique identifier here. And this unique identifier is immutable. when you invoke the new operator in Java, and when you are going to delete this entity after 3 years, the UUID is always the same. Okay? So I'm generating the UUID, and my hashcode and equals implementations are all based on UUID. Okay? And this is real immutable field. But the problem is that UUID is 36 digits, which means I need to save 36 digits more for each single entity, which can be a huge problem. Okay? There is some blog post on Percona blog when they are trying to persist UUID as some binary form. Okay? But still serializing it and deserializing from this field it's a problem, and there is no database that has or hibernate dialect that is able to save UUID as some binary element. We can do that. We can create our own hibernate dialect basing on some MySQL Postgres dialect, and remember that, okay, if you have a field which is UUID, not string, but we need to use the UUID field, then persist it as some, I don't know, strange stuff, okay? But still, indexing such long and random string is not going to work, okay? So it's a problem. But as I know, it's the best implementation for handling this unique identity of the entity. Okay? So now let's move to another topic, which is also really important, and it's the caching. We have 3 levels of caching in Hibernate. It's the level 1 cache, which is a session cache, level 2 cache, L2, which is a session factory cache, and a query cache. Okay? And the L1 cache is default and it's turned on by default, and there is no way to turn it off. Level 2 cache and the query cache, it can be turned on by you to improve the performance, but you need to still check if, for example, enabling query cache is helping you or is decreasing the performance, because it depends. Okay, and now, when we are talking about the cache, we need to cover the flash modes. Why? Because every time when you change something in Hibernate, when you save the new entity, when you persist it or something like that, it's not automatically flashed into the database. It lives only inside your level 1 cache, which is a, let's say, buffer for the Hibernate engine. Okay? And there are 4 flash modes. By flash, we mean please hibernate. Transfer those entities and all those changes from your buffer, so from L1 cache, to the database. Okay, and there are 4 types. Manual, so only when you invoke the entity manager flash, those entities will be flashed. Commit, so only when you commit, those elements are flashed to the database. And there is auto, which is not the same as commit, because auto is commit, and every time when Hibernate realizes that you want to ask for some entity, and Hibernate keeps the entity of the same type inside the cache, okay, it needs to save it, so you will be able to, for example, retrieve it using some native query or some HQL query, etc. Okay, and there is always, so before any statement, any query, please flash everything to the database. And why it's important? Because the biggest pitfall of the level 1 cache is how we deal with the batch statements. If I'm inserting some entities in batch, then it means that I'm inserting those entities into the L1 cache. And this L1 cache is huge. And if you want to send it to the database, you need to invoke the flash. So the idea is that every 1,000 of the entities, I will flash them into the database. But if you want to invoke the clear after flashing, then in the next iteration, you will be flashing 2,000 entities. And in the next iteration, you will be flashing 3,000 of the entities. Of course, Hibernate won't flash those entities one more time, but it needs to check if it's worth flashing or not. And the difference between clearing and not clearing the L1 cache before the flash is like with clearing, some batch processing will take, let's say, 30 seconds, and without clearing, it will take like 10 minutes. Okay, so it's worth to remember about that. It's also worth to remember that invoking clear before the flash, it's not the best idea, as all your changes lives only in one L1 cache. So if you will clear and then flash, it means that all your job was just thrown out. Okay, so the really important thing to remember about the L1 cache. Next important thing is the second level cache. We often use second level cache to improve the performance of the whole idea. But if you are working in a distributed environment, it means that I have two instances of my application. Okay, I'm saving some entity on the first instance, and then loading this entity on the second instance. And that's great because there is consistency. But when I will change this entity on the second instance, it's flashed to the database, but it's not present. This new version is not present on the first instance. So if you are not now going to change anything or retrieve something on the first instance, you will say, oh, I have it in my cache, so I will use it. Okay? So if you want to use second level cache and you are working in a distributed environment, you need to replicate your cache. You need to use some clustered cache, like, for example, Hazelcast, which is, as far as I know, the best implementation for the second level cache in Java, because there is no JGroups problems, okay? If you are familiar with cache or some other stuff like Infinite-Spander, a lot of problems with JGroups and clustering when you don't want to use multicast or something like that, okay? Hazelcast just works. It can also work as an embedded solution, and it's also free. So Hazelcast is the best second level cache implementation in a JPA world, okay? And the last thing I'm going to cover today, it's something I call the HQL injection, okay? The problem is that, The problem is that we all know that we need to bind parameters to prepared statements because there will be a SQL injection, okay? And when you take a look at OWASP top 10, so top 10 security problems in application, then still the SQL injection is on the first place. And why? We are using hibernate, okay? So I know that I need to bind parameters in a prepared statement, but it's not a prepared statement, it's hibernate statement, and hibernate operates on objects, not on a SQL queries or tables or something other ugly stuff, okay? So I don't need to use binded parameters here because hibernate is smart. It will protect me, okay? No, it won't. If you will use something like this, of course, hibernate will change this one for the object for the SQL query, which will be select some aliases from products, aliases, where aliases, but category will be just copy-pasted from here, okay? So there is totally no SQL injection protection, even if you are using Hibernate query language or Java persistence query language. You still need to bind parameters, okay? Of course, we are not just using some simple string concatenation, but I saw tons of examples when people were using string buffer or string builder to create some complex query, because when we are going to use binded parameters, then I will need to take and maintain some map for the parameters, and it's hard, so it's better to use string buffer, okay? It's not because you are facing the HQL injection problem, okay? And if you want to learn more about this topic, there is great, brilliant book by Vlad Michalcea, which is a high-performance Java persistence. It's published on LeanPub, and it's the book that every Java developer that is working with databases must read. Really brilliant book. Also, the blog of Vlad. There is also a lot of great examples. Vlad is working for over a year inside the Hibernate core team. He's one of the principal developers in Hibernate. So he really knows how it works. If you say, okay, this all is hard, there are a lot of problems, we want to take more from the SQL, there is some library called Juke, written by Lucas Eder. It's a great alternative for the JPA, and I'm not talking that you should throw out the JPA today and all move to Juke, but it's good to know the alternatives, as Juke allows you to invoke all advanced SQL queries like windowing functions or something like that, and there is a lot of cool information at the Juke blog. Also, please take a look at your Hibernate logs, because if you want to understand how Hibernate works, why there is such information in Hibernate, why there are two linking tables or something like that, you just need to read logs, because there is everything, okay? When you are removing something from the bag and you see that there are tens of SQL statements and you are expecting one, then you see, okay, there is something wrong here, okay? So please read your Hibernate logs, and it's also good to debug Hibernate code when you see that something is really strange. When you see that access to the query cache takes longer than executing a query to the database, then it's good to dig into the Hibernate code and see why it's happening in this way, okay? I don't think we have any time for questions, but I will be here for a few minutes, so if you have any questions, just don't hesitate to ask me. Thank you very much, and have a nice conference.